And I wanted to do that right up front because a lot of people don't believe when we tell them, if you've got a lot of things on a graphic and you're focusing on a problem, you can really miss a critical piece of information. That grill was there for 19 seconds. Came in and beat its chest, right? It was there for 19 seconds, right? And that's often when a manager gets an operator in and says, how could you miss that alarm? That was there for 19 seconds. It was on the screen flashing bright red at you, right? And it's very, very easy to miss it. So we use that as an introduction to situation awareness. So basically we want to start by really sort of saying, do you have a vision to really address situation awareness? Do you have alarm issues today, okay, where operators get lots of alarms and get overwhelmed by alarms? Are your HMI graphics more colourful than a rainbow? Do you have challenges with multiple systems? You have safety systems, you have process control systems, you have vibration systems, right? You might start getting systems in the future that are bringing more information in from the field, okay? As you start going to things like field bus, you start getting information around the valve, right? So you have multiple systems. How do you disperse that information now? Who should be getting that type of information? Do you have a migration strategy as you're looking at moving to your next generation technology DCS? And one of the big questions we often get from the operator is they say, in the old days we used to have a big picture, right? And we missed that big picture, right? And basically today the DCS is like looking through a keyhole at a vast amount of data. So we asked the question, how does an operator know what is going on? Well, obviously today we have instrumentation, we have information coming in through the DCS, and it brings information in three different forms, and we're limited to information coming in from the field. As we move to remote control rooms, the problem gets a little bit worse, okay? So we really have to start addressing those issues, and we can address those issues, and we do a good job today at addressing those issues. Today we can use acoustic sensors to actually detect those noises and bring those noises in the control room, and we can actually bring them in on a microphone. So if the noise changes, we can audibly bring that noise in the control room. We can audibly detect it and then switch cameras so you can actually look at something as well. So there's lots of things we can do today to improve situation awareness. Basically, we need to think about fatigue and what are the countermeasures today that we can use to address those fatigue issues so that an operator is alert and ready to take action. So the environment plays a big part in situation awareness. And most of our control rooms today are completely the opposite from a fatigue countermeasure. They're somewhere that promotes sleep because they're dark, the air conditioning systems don't work very well, very variable. Some operators are either too hot or too cold, and we never find the right balance. But the other part of our control rooms today is they're noisy, we've got distractions, we've got poor lighting, we've got poor ergonomics. So we're not doing a very good job as far as situation awareness is concerned. I want to try and introduce some topics today to really address situation awareness. So first of all, I want to define it. And if you're a company that's striving for operational excellence, within operational excellence what you will find is there is a definition. Good situation awareness is achieving high performance in preventing abnormal situations. Basically, it introduces a topic about how the work environment can be designed to provide good situation awareness and a proactive operating stance. Now I say proactive operating stance because over the past few years, we've gone from operators that were very proactive when we had panels to operators that are becoming more reactive and waiting for an alarm. And again, that's not a good situation to be in. And I want to show you why that's not a good situation to be in. Let me give you an example of what I mean by this process of situation awareness. An operator, first of all, has to become aware of a changing situation. That often is by a noise, an alarm, okay? Now before the operator often takes action, it often goes into a mode of confirmation. And that may be calling up a colleague and trying to find out whether he confirms that this is the situation they're actually in. Here's our confirmation. Now, if the process of detecting and analysing is too late, by the time we get to the action, it's too late. And that's a very good demonstration of it, okay? That three-stage process. So today when you hear about grids, electrical grids, falling down because the operator got the alarm but didn't respond fast enough, that's the process that he was going through, and those were the delays. And what we see as we go through incident reports, basically we study this whole area. So here's the operator, he's effectively isolated from the plant by a wall, and he's basically got these sensors. Move on, Dave, please. And he goes through this process. He uses those external sensors to basically orientate him around the problem. There's an analysis and thinking and an interpretation phase, and then there's a physical or verbal response phase, and then obviously we have some form of output and we get some form of feedback. But as we look at that loop and we go back through incident reports, what we find through many incident reports is that we fail in these three areas. And the type of failures focus on, first of all, this very first one, orientation. 30% of incident reports end up in this section here, where an operator didn't detect the problem because of something like information overload. Now, if you think about that, that is the alarm system, okay? Why did he miss that important alarm? He was just overwhelmed in it. Why did he miss that changing information on the graphic? And we've just proved that because there was too much other information going on. There was too many things going on the graphic for him to be able to see it. In other words, a gorilla came right through the screen and you didn't see it. Vague, misleading information, inappropriate levels of detail, and again, we talked about this vigilance area. Again, that's a big one that is contributing to these 30% of incidents. So if 30% of our incidents we never ever get focused on the problem, that's an issue for us. We've got to address that issue. In that evaluation stage, we found another 20% of incidents were focused in this particular area, and the main causations were insufficient knowledge, lack of experience or practice. And again, you've identified, so a lot of you told me that this week, new operators haven't seen many of the things, right? So you don't get a chance to get exposed to them because the plants generally run well. Conflicting priorities, inaccurate labeling and information presentation. And the other one is this excessive mental tasks. If we add these two together, 50% of the time, before an operator ever takes an action, we failed. That's not a good situation to be in. So we have a problem today with situation awareness that we've got to address. And then there's a whole series of things in the acting stage. I'm not even going to go into those. So we want to focus on what our appreciation of operation situation awareness is through these three areas: the alarm management, the human-computer interface, and the control room design. Alarms, obviously, is a big one for us. But what we want to say about alarms is that alarms are just one of the tools in our toolbox to address situation awareness. Unfortunately, we've over-biased that, right? And we have far too many alarms today. And part of the issue is a lot of those alarms need to be prioritized and they're not. They need to be relevant and they're not. They should always require an operator action, but we see many that are not. It requires the operator to be knowledgeable of what the alarm is and how to respond to it. And again, often we don't, not always have that. It requires the operator to know what actually the consequences are of not responding to that alarm. And what you'll find is that it's not documented. It should be documented. That's the first thing that should be documented on every alarm system, is why the alarm exists, what's the appropriate action for that alarm, and what are the consequences of inappropriate action. And that should be able to look that up on any alarm that comes on the system. So just to prove this, Texaco Pembroke, right? Silver in the UK, in Wales. 24th of July 1994. Typical day on the plant. Electrical storm comes over, which isn't unusual for that part of the world. The crude unit was hit by a bolt of electricity. Hit one of the instruments. The crude unit went into a shutdown. Did exactly what it was supposed to do, exactly as it was designed to do. Shouldn't have been a problem. Several other units were affected because the crude unit is the main feed unit for a lot of these other units. So most of the units went into a shutdown mode. About 5 hours after this initial incident, there was a large explosion. The explosion involved 20 tons of hydrocarbon, equivalent to 4 tons of high explosive. There were 26 injuries. This could have been a lot worse than this. Fortunately, we found an ignition source very early. There was a lot of inventory to make this explosion even worse, okay? And the reason why there wasn't many people injured, it was a holiday weekend, just like the Flixborough one, right? And there wasn't many people around on the plant. And that's the thing that saved this particular incident. This is what happened. It was on the main flare line. Another picture of it. And again, car cracker was down for 2 years, very costly. But in the analysis of this incident, they said the alarm system during the incident, the DCS display conveyed limited information. The health and safety executive, which is equivalent to our OSHA, said that the flood of alarms greatly decreased the chances of the operator restoring control of the plant. Alarms were being presented at 20 to 30 per minute. In the final 11 minutes, the operator received 275 alarms. Over 2,000 alarms were configured. 87% of them were configured high priority. There was only one emergency priority alarm configured in the system, and critical alarms were overlooked in the midst of all of the other alarms. As most incidents, the HSE determined that the alarm system wasn't the only cause. In an organisational type accident, there are multiple things that come together. Well, basically, you've got to look at what are some of those initiating causes. And one of the things they focused on was the poor control panel layout. The important information was not properly highlighted, and there was a lack of an adequate overview display. That one sentence has started to change the way we are thinking about control rooms, control room alarms, and control room displays. That thing about what operators said about the big picture is focused in this incident report, and we should learn a lesson from it. 2 key contributions. And basically, this is one of the ones we want to focus on, the plethora of alarms triggered in the control room, many of which were unnecessary and registering with increasing frequency, so operators were unable to appreciate what was actually happening. And again, the use and configuration of alarms should be such that safety critical alarms are distinguishable from all other alarms. Alarms are limited to the number that an operator can effectively monitor. There is a body today, and basically the body is called EMUA, E-E-M-U-A. They have become the de facto standard worldwide. They brought out a document, EMUA 191. It had input from the US through the Abnormal Situation Management Consortium, which was built up of ExxonMobil, Shell, Chevron, BP, all the big ones, all the big companies. All the chemicals were in there, the Dow chemicals were in there, Unicarbide was in that mix, okay? All of them basically pulled out the best practices in alarm management and put them into that EMUA 191 document so that it became a guideline for the industry. So today, we have statistics from there that tell us what is the maximum number of alarms that an operator can manage, okay? And basically in normal operations, it says 1 every 10 seconds. And during an alarm flood, we shouldn't exceed more than 10 every 10 seconds. So we actually have some benchmarks now to measure ourselves against that. The other thing they came up with and said was that the use of configuration of alarms should be such that the safety critical alarms are distinguished by other operating alarms should be limited to the number of operators can effectively monitor, then the display system should be configured to provide an overview condition of the process. Now we've got to really define and understand what they mean by what is an overview of the process. An operator often looks after multiple units, right? So one of the things that we know from this statement now is that if you're looking after 3 units, the 3 units should always be on permanent display in front of the operator. So if he's focused on one area or one unit, he can still see what's going on in the others. So again, we learned something. Operators should know how to carry out simple volumetric and mass balance checks. But if we go back to Texaco Pembroke, and I don't want to pick on Texaco because Texaco is a good company, okay? And they're the same as everybody else. They were no different to everybody else in the industry. But Texaco had a culture that said they ignored alarms. They had alarms that had no operator action. They had poor prioritization of alarms. They had a lot of standing or stale alarms, pages of them, and again I've seen similar things here this week. They had many bad actors, and I don't mean Clint Eastwood at all. What we mean by that is that there were instruments that were giving alarms that were not useful, okay, at frequency. And again, a lot of it was either because the instrument wasn't set up correctly or the alarm wasn't set up correctly. Okay, could be fixed. They had alarm floods on a regular basis. And what we see with, if we have an alarm system that is badly designed, you will see more alarm floods. As you get your alarms under control, the floods start reducing. 2 things go together. They had poor human-machine interface. Navigation of their graphics was poor. There was no hierarchy in the graphics. They had many colors on their screens, and they never reserved colors for alarms. Most companies today use red for multiple things. In fact, when we actually studied the Texaco thing, the number of occasions they used red, they had 13 different things that red was used for, as well as being a critical alarm. So red never stood out as being important, right? Whereas if they'd only ever used red for the alarm, at least it would have given the operator a chance to say, if there's something red on the screen, I've got to really respond. So today we reserve colours like red and yellow just for alarms. We don't use it for anything else. We find some other way of indicating other things. So today we have a way of looking at several units and looking at metrics for the alarm system, benchmark of the alarm system, where the alarm system should be. Okay? And again, there's different ways of looking at it. And not just the alarms, but what we've seen is, as an operator doing many alarms, it often means he's doing many moves on the control system. That means the control system is not doing what it's supposed to do. In other words, it's not in automatic control. It means the operator's putting it into manual and making moves. Okay? And we can actually measure those moves, and today, again, we have a metric which says, this is typically the number of moves the operator should be making in an hour. But look at the spikes, right? But the number of moves the operator is actually making. And again, and what we've seen as a company starts to address these issues, because it's important. If it's not in automatic control, your advanced control, you've just wasted all your money. You're not in advanced control, right? And this one plant here, these were the number of moves that the operator was making on a regular basis. And when we fix the alarm system, this is now the moves the operator's making. What difference do you think that makes to your business? If you're not addressing alarms every 10 seconds, right? You're not making lots of moves, and it's in automatic, it's doing what it's supposed to do. Go through your alarm system and start generating some metrics, and we're going to do that partly for the study we're doing today with the staffing. We're going to take a snapshot of the alarm system to see how it's impacting the operators. And we want the number of operator moves. Every alarm should have an operator action. If there's no operator action, it shouldn't be an alarm. Every alarm should have a priority, and that priority needs to be well thought out. Alarms should be within the EMUA KPI range. If the prioritization based on EMUA is not followed, you should be doing a workload assessment to figure out how many operators you actually need. Because the chances are you're overwhelming one operator, and one operator cannot cope with that system. If alarms are removed, you've got to do something different, because alarms are a tool in situation awareness. Today we've loaded up the alarm system, and our dependence on the alarm system, we haven't done much with the graphics, right? So if you want to start reducing alarms, guess what you've got to do? You've got to start making improvements so operators can detect things through the graphic system. In the old days when we had panels, we had lots of trends. And because we had lots of trends, operators had good situation where they saw something moving out of control. They were often on it a long time before the alarm ever came in. And so our dependence on alarms was not as great as it is today. In fact, if you go back to some of your panels, you may have had something like 72 alarms for the whole plant. And now with the DCS, because it's easy to add alarms, you've gone from 72 alarms to 4,000 alarms, right? And you aren't any better off. You're actually worse off than having just the 72 alarms, because the alarms just overwhelm the operator. So if we're going to reduce those alarms, we've got to think about how do we bring back situation awareness through graphic and trending. And today, we've seen very little use of trending. That's not a good thing, because trending was a great situation awareness tool. We used to have a terminology we had in the old days on panels, where the operator used to look down the panel, and everything was calibrated so that when it was good, it was always on a straight line in the middle, down all the trends. And you could stand there and you could look down the panel and you see everything in a complete straight line. You said, everything's lined out today and it's good. And if something was out of shape, it would be out of line. And it was easy to spot it. And we were able to come into the control room, and we used our human skills of pattern recognition to be able to identify that was a problem. Then we used to go and focus in on it and figure out what was going on. Supervisors used to come in the control room, and they'd not even paying any attention. They'd walk down towards the operator and they'd go, that doesn't look right. And they'd spot something immediately. The customer I showed you the data from, the one who went back and you saw the reduction in the number of operator moves, this is their data. They went from 1.5 alarms per minute, 180 minutes, which is 25% of the shifts spent on alarms on one unit. 25% of the shifts spent on alarms. They're now at 0.3 alarms per minute, so they're only spending 5% of their time on alarms. The total time they were spending on alarms was 6.9 hours per shift. So if I fix the alarm system, I've just created a whole half operator. How would you like a free half operator? Right? They're now only spending 2.39 hours. They've still got work to do. They're getting better. And that was only based on 10 seconds per alarm. And I'm sure some of the things the operator was spending more than 10 seconds on some of those alarms. So it just goes to show you we can actually create over 4 hours to focus now on performance rather than just addressing alarms. The culture that this company now has is they have a culture of resolving and reducing alarms. All alarms have an operator action. All alarms are prioritized and balanced between those priorities. Okay, they do against us a guidance about how many high priority alarms we should have, as against medium priority, as against low priority. Obviously, we've got to have a balance. They have no standing and still alarms, and they have what we call a black screen philosophy. So if something's out for maintenance, that alarm is removed from the system. It's removed from the screen, maybe still recorded somewhere in a journal, but it's not up there in front of the operator, because it's not recorded. They resolve bad actors every week. They have a top 10 list that they work through on their alarm system. They have an understanding of resolving alarm floods. They're starting now to get more data and appreciation about what is within an alarm flood. They now have a good HMI because they didn't just try reducing alarms, they improved their graphical systems. They have navigation that supports operator tasks. Rather than just have a P&ID, right, and goes from the end of the P&ID to the next picture, the next picture, next picture, and you find that operators have to jump around different screens to get information. So they have a hierarchy that's good for diagnostic techniques. They've restricted colours and reserved colours for alarms, and they've moved to something we call cool graphics. I'm going to introduce cool graphics to you, because cool graphics are a whole new concept, and most of the industry is moving to cool graphics. And when I talk about cool graphics, it's a way of moving from black backgrounds to grayscale backgrounds. Not using colours, or reducing the number of colours we're using, and basically reserving colours so that when we do use colour, it's for something that has a good reason to use colour. Okay? And basically, they went through their alarm system and went through a 7-step approach of addressing their alarm system. But we found that successful alarm management projects are really dependent on the user's understanding that the alarm is only one of the tools in the control engineer's toolbox. Good user interface can be more of a benefit, and having a proactive user interface rather than a reactive alarm system makes for a better plant. Before, DCS operators relied on trends and anticipated problems. So how can we create an environment so that the operator can perform optimally? Again, using that same customer, we went through what are all the issues that they have, from the control issues, the alarm issues, the graphics issues, the procedure issues, the training issues, and we just documented them all in this type of format. We went through looking at statistics on their alarms, and basically what we saw was alarm rates of 73 per hour, which is 1 every 49 seconds. On a bad day, that increased to 693 per hour. On a really bad day, they went to 13,450 alarms per hour, right? So we went through a strategy of looking at alarms and graphics. First of all, rationalization of the alarm system, where we reprioritized, renamed, consolidated, documented, revisited alarm limits. No action, no alarm, got rid of it. Then we went to smart alarming, where we looked at how we shelve alarms, first out alarming, do more dependent suppression, and then offline suppression. So we got rid of some of those standing alarms. And then basically the next phase was go to what we call the ASM graphic standards. And what we saw was, we saw this reduction in their alarms, which was very impressive. And if you look at the time scale between November and February, just on one unit. That made a dramatic impact to that plant. It also made an impact to some of their key performance indicators.